Hello, I'm Mark, and welcome to my Unreal Engine tutorial on how to build a data-driven music management component for your Unreal Engine games. This little management component will allow us to manage our music tracks in a central location, as well as organize our music into playlists, as seen in this data table right here, music playlist. Also, what we'll also do a little bit later in this tutorial will allow us to create a little UI, which will also allow us to change the music within the game. We'll be able to pause, change the track, change the tune, and so on. So, without further ado, let's get started in this endeavor. So the first thing what we'll do is we'll come in and we need to create a solution. So I'm using a third-person solution. I'm going to be using C++, setting up for desktop, and I like to always make things scalable. And then we'll just give ourselves a solution name. Now, I'm not going to go ahead and create this since it takes a little bit of time for Unreal Engine to create a solution, especially when I'm recording this. But I have one already pre-baked, but you go ahead, follow these instructions, give it a name, and then just hit the create button and let Unreal Engine do the rest. Once Unreal Engine's built it, you should get ourselves a little solution like this. So the first thing we're going to want to do is we're going to want to define our data structures, and there'll be two data structures we'll want to build. So we'll come down to C++ classes. My project's called Core Music Live, so we'll just put it in here. And we'll hit new C++ class. So to create structures within Unreal Engine, we'll pick the none, and we'll come to next. I'm going to go ahead and select the class type as being public, and just for organization, we'll call this music, and we'll give this thing a name. So let's go ahead and give this guy a name, and this one will be called music track. So I'm just going to go ahead, music track, hit create, and we'll let the Unreal Engine go ahead and create that code template for us. Now it's compiling. And we should have a good compile. So we'll go ahead, reload, and let's go ahead and define our music. Define our music track structure. So first thing we're going to do is we're going to go ahead and convert this from a class to a struct. So to do that, we'll go ahead and add the useStruct meta tab up there. Of course, Unreal Engine's or Visual Studio is going to be running its IntelliSense. So we'll define this as a struct. All structs in Unreal Engine have a prefix of F, so it's now a F music track. But we'll also want to make sure that this struct gets generated correctly. So we also need to add the music track .generated.h include, and always make sure that this is the last include line in your include stack. Next, we need to add the compiler macro up there to generate the body, and then once we have that, we can just go ahead and just round the music track out a little bit. And let's just go ahead and fix this. So I'm just going to go ahead, potential fixes. I'm just going to go ahead and delete these two functions and replace them with our renamed functions. All right, so next up, let's go ahead and define the attributes of our music track. So first up, we need a name. So I'm going to use an ftext name. And then we're just going to make this standard blueprint, read, writable, and then edit anywhere. And for the properties, we'll go ahead and give this a description. So that way we can, if there's anything that we need additional text outside of the name, we can go ahead and put that in there. And since we are dealing with music, which could be, which is probably going to be done by a third party or a third person. We should always put a little block. I'm going to put a little block there to credit. That way I can always credit the author or credit the composer of music. Next, we're going to have a pointer to our usound base. So this is going to point to the actual source track. And we're just going to preset that to null. And then we're just going to add a couple of properties. So in case, for tuning our sound. So first one is going to be volume multiplier. Then we have a pitch multiplier, and we're just going to set these to just 1.0, 1.0. And then also we've got our persist across level transaction, and we're going to, by default, I'm just going to set this to true. And these are all properties which will be needed when we want to go and spawn a new audio component in our Music Manager. So that's it for just the music track. So now the next structure we need to build is the playlist. So again, we'll just go back to our editor. We'll pop this open. We'll go to the content drawer. And I will just go ahead and go back to core, new class, and we'll hit next, make it public. Set it to the music folder, and this structure will be our playlist or playlist catalog. And this is the actual row component that makes up our data table. So we'll call this playlist row for this demo. So playlist row, public, set to music. We'll go ahead and create the class. Let Unreal Engine do its thing. And there we go. And we should have another component, which is our playlist. So I'm just going to go ahead and close that. Let's go ahead and transform this into a structure first. So the first thing we want to do is we want to have, I'm going to put a pointer to our music track. Next up, we want to add our generate include statement. So we'll go ahead and do that there. So playlist row. We'll give it the F prefix, since all structures in Unreal Engine start with a prefix of F. And we will call this a struct. And we'll go ahead and add our little decorator up top, uStruct blueprint type, as well as the generate body. And we'll go ahead and do that right there. Okay, we'll go ahead and fix the list row. So let's go ahead and just fix these. Just make sure our constructor and our destructor. So everything looks like it's happy. And then what we'll do is we'll go ahead and add our properties. So we'll go ahead and add a name. We'll also go ahead, once again, we'll also add a description, and we're going to be using ftext for that. And then lastly, we'll go ahead and add the actual list itself. These are the list of music tracks which are part of this playlist. And for that, I'm going to use a map. So we'll use tmap, and we'll give it use the f name as the index, and then we'll be using the music track as the object which is being held in this playlist. So the last thing that we need to do is we need to turn this into a row so it can be made into a data table within Unreal Engine. And in order to do that, we just need to do two more things. We need to, first off, need to go ahead and add the include file, which is engine datatable.h. And then what we need to do is we need to have this structure inherit from Unreal Engine's ftables row base class. So once we have this, and we'll save it, this class will now go ahead and inherit, now becomes a table row, which can, so this class can now be used as a row structure in an Unreal Engine table. And then the last thing I want to do here, which will make our lives a little bit easier later on, is to create an overloaded constructor. So this is going to be fPlaylistRow, not catalog. So fPlaylistRow, and it's going to take in a text name, which will map to the name, and a description will match to the description. And we'll go into this in a little bit more detail when we actually get to the component code. But we'll go ahead and map these. So name equals name, and description equals description, and make sure that make sure that name is equal to name and description is equal to description, so you don't get a recursion. That way you're not in danger of getting any recursion happening within this constructor. Okie dokie. So now that that's all done, and we've got our default constructor set up, as well as our overloaded constructor here, I think we're good for data structures. So now let's go ahead and move on to the core components that we'll be using to help play and manage our music. So to do that, once again, we'll come back to our Unreal Engine. We'll open this up, we'll go to core, we'll go to music, we'll hit new class. Now for this, I'm actually going to go ahead, since I'm not going to be adding this to a character or to the controller, but instead to the game instance, I'm going to want to just make this a basic object. So to do that, we're going to come to all classes, and we're just going to select object up here. From there, we'll just go next, and then we'll go ahead and give this object a name. So go ahead, and I'm going to go ahead and just call it Core Music System, but you can call it whatever you like. It's going to be public, and then the folder, again, I'm just going to put it under music so that it's all nicely organized. So then we'll go ahead and say create, and then we'll go ahead and let Unreal Engine create that object template for us to use. And it's created, everything's compiled nicely. So now we can come to our music system. So this, whenever we're creating an object, it's going to derive from uObject. There's the name, there's the generated, and everything looks good. So first off, let's go ahead and set up our headers. So the first thing we want to do is, since this is going to be running and managing an audio component, we're going to include from components the audio components. We're also going to include music track, which is our music track. And I think that will do it. Next, what I'm going to do is we need to make sure that our object can also be seen within a blueprint in the editor. So we'll go ahead and add the U class with the following attributes: blueprintable, default to instance, and edit in new line. And then what we'll do is we'll go ahead and set up, just do a little bit more setup. We'll create our public, our protected area, and again another public. So under this, what we'll do is we'll just go ahead and just create a generic default constructor. And that will just set our constructor up. So we'll go show potential fixes. Next, what we'll do is we'll go ahead and define the attributes that we want within our component. So the most important one being our audio component. So we'll set that up as audio component pointer, and we'll just call our audio component music component, and we'll give it the U property so that it can, when this component is registered with the garbage collector, Unreal Engine's garbage collector, it'll be able to function properly. Okay, next up, we'll go ahead and create some attributes that we can use to help manage our playlists. So first up will be the current playlist. So, and I'm going to just default that to global music for now. So there it is. And again, this will be editor defaults only, read write, and then we'll create a new category. We're going to create a category called music system. Next, we're going to go and create our playlist, which is a data table. So this will allow us to hook a Unreal Engine data table straight in. Again, set as a null pointer for now. We'll go ahead and configure this once we turn this into a blueprint, or from the blueprints. I'm going to just add a little variable here for debugging purposes. So this will allow me to turn any debugging messages on and off, from the blueprint. And then I'm just going to add a couple more variables, which we can get into later, but we'll add them in now. The first one is going to be a min seconds between track and a max seconds between track, and this will allow me to create a little bit of, so if I wanted to track to, just instead of just play once, but play in a repeated manner, or if I just want the playlist to play through the list and then go back to the beginning again, I might want to have some time between the tracks so that it just, and give it a little bit of variance, so it doesn't feel like it's playing one after the other, bam bam bam. So to do that, we'll go ahead and add that information. And so I'm also going to add the ability to select how I want to play the music, from the component. And to do that, I'm going to bring in an enumerator. So to do that, we'll create an enum. I'm going to call it core music player state. We'll give it the decorator of enum blueprintable, and then we'll have a none state, which pretty much means play once and that's it. We'll create a repeat track where it'll say, okay, let's just keep repeating the same music over and the same track over and over again. We'll also create a repeat list, which will allow us to go through the playlist, and then once it gets to the end, it can come back. And then we'll also create a repeat shuffle, which will pretty much pick a music track at random and just play it once the last track is finished. So that's that, and we will want to make sure that we're managing that state. So we'll just go ahead and add that enum down here. So again, we'll make this so that we can manage this from the blueprint. And so enum as bytes, the type that we want, give it a variable name, and by default we're going to set this to none. Okay, once we've defined all the things that we want to be able to manipulate from the blueprint, let's go ahead and add some additional internal variables which we want to just keep protected. So let's go ahead. So the two variables that we're going to add to help manage our music as we're playing it is the current time delta, and this will allow us to determine where we are, as we're ticking through after a music track has stopped, and determine whether we're going to be playing the next track or not. And then we have next track delta time, which will be the actual time that we actually will be playing based on the min-max created here. We'll also have a placeholder, so we'll know what track we're currently playing within the playlist. Okay, then next up, let's define some game logic or music logic internally for our manager to manage. So we'll add the implementation once we've defined our code up here, but I've got a simple little function which I can then, again, as you can see, I've got the ability to turn debugging on and off, and this will just allow me to just output from the code any error messages, and I'll go into how that's going to work. We've got the get soundtrack by ID. This is the most important one. This is the one which will interact with the table and find the track to pull back. Is valid playlist table. This is the one. This is a function that I create whenever dealing with data tables to make sure that there is a data table that is mapped in the blueprint. Because if not, that's one good way to crash your Unreal Engine. Can play next track. This is just here to determine whether we can actually, whether we can play the track, and that's going to be done over delta time. And then this is the run music state, which will determine based on the music state here, which one is it going to do? Is it going to play it? Is it going to play it at all? Repeat the list, or shuffle the playlist? And then lastly, we have the set track delta time, which was just a simple little function which will pretty much get a random number between the min and the max, and then set that variable there. Okay, and that's it for protected. So let's go ahead and get our public methods. So the first one that we're going to go and create is a simple little void init. This is just a simple little initialization function. There's no function property on here. I just want to keep this internal, without so that it can't be used by any blueprints. Next up, I'm going to add the core music track. So again, or core music tick. So this was what I'm going to be tying into either the maps tick when we kind of incorporate it into the map. That way, I'll know roughly how much time has elapsed since I'll be putting this into the game instance. There's several ways we could do this. I just find this is probably one of the easier ways just to implement, and just by just piggybacking off the maps tick since it's there. We'll also add a function called set playlist ID, and this will allow us to programmatically set that playlist to whichever playlist we want to use when we want to use it. We'll also get a set playlist state, same idea. So if by default we set to none, but we want to change it at any time based on map or based on a UI, we can go ahead and do it right here, and then that'll just change the core component for us. I'm going to add two functions or methods, depending on what you want to call it. One is the playlist category or row. Apologize, I'm pulling this from another solution. Just make sure that it all lines up. All right, I can also just say just include it up there, playlist row.h, and that will satisfy that. And I'm also going to go ahead and add another function, and I'll use some of these functions when we're dealing with the UI component. But this will allow us to just get the metadata out so that we can then use that from a UI in the UI. Another thing we're going to do is add play music track. This is the most important one. This is where we'll put the track ID in, and it will then go ahead and play the music that we want it to play, as long as that. We're going to have the play next music track. This will be very useful later on when we start saying, okay, let's play the entire list instead of just one track. I'm also going to go ahead and say pause current track. So this will, so if you're playing music and then you want to pause because you want to bring in other sounds, like say you've got dialogue or other things and you don't want the music to kind of, muscle out any other sounds, you can temporarily pause the music and then start it back up again, and it'll just take the Boolean variable. We're also going to put a stop track so that anytime we can actually stop the music, in the middle of playing versus pause it. And then we're also going to have a little Boolean function to check to make sure to see if the music is actually playing. So that is it. So let's go ahead and move over to the implementation of these methods. So first off, we'll start with the error message. So I'll get that up and running first. So this one's just a very simple one, and I'm just going to go ahead and just bring this over. So pretty much it's going to check to see if that debug variable is there. If that debug variable is there, then as long as the engine is valid, it'll go ahead and just do the add on-screen debug message. We'll set this for, I think 15 seconds is a little too long. I'm just going to say 5 seconds. And we'll make it the color red. So that's pretty much it. If you want to change that from using the on-screen to logging, you could do that, or you could probably put something in the else statement to say, if this is on, put it in there. Otherwise, if not, output to the log. I'm just going to use for this demo, I'm just going to go ahead and just output to the screen if debugging is turned on. Okay. Next up is going to be get soundtrack by ID. So we'll go ahead and open this, and this is pretty much the main function that we'll be using to find our soundtrack, and once we find it, we'll then return the soundtrack out. So the first thing we will do in this function is going to be always to make sure that that data table is valid. So again, is valid playlist table. So if this comes back as being, if the data table's not hooked up, it'll come back false, and will automatically say that we can't get the soundtrack, which will then pretty much abort us from trying to play. Next, if we are good and we do have a valid data table there, then we'll go ahead and want to go and query the table and bring back our records. So we'll get the F playlist row. So F playlist row of type playlist, and this is just going to bring back a pointer to the record on the table, and that we'll do this by the current playlist ID. So we'll always set the playlist ID first. So, but this will bring back the entire playlist, and then once we have the playlist that we want, since our table can hold multiple playlists, so we'll find the playlist that we want, and then from there we'll go ahead and then query the playlist. So to do that, what we'll do is we'll do an if statement. So we'll check to see, so what this will do is it'll, check to make sure that this playlist is valid, right? So we could have this could be set to a string that isn't indexed in the table. So we could have 0 playlist come back. If we can't find the playlist, it'll come back as a null pointer. Also, if someone was to configure the wrong table in there, since it's loosely coupled, it can also come back as a null pointer. So we want to make sure that this thing, is a valid pointer, reference pointer, and once it's valid, then we can go ahead and use it. So from there, what we'll do is we're going to do two things. We're going to say, if we have a track ID coming in, we'll then go ahead and find the actual track on the playlist. Otherwise, if this is none or we've not set the track ID, then we'll just go ahead and just randomly pick a track from the playlist. So to do that, what we'll do is we'll say if, we'll go track ID dot is none, and then we'll just go ahead and use that. So the track, the fname structure has a little method on there to check to see if there's actually anything in there. And if that's none, then what we'll do is the first thing we'll do is we'll go ahead, since the playlist uses keys, we'll want to go ahead and get those keys. So playlist and then playlist dot get keys. This maps to, so if we bring up the playlist, this is our playlist right here. So this is the actual list. Since this is a map, what you want to do first, in order to iterate through this or loop through it, we want to get a list of all the keys that are available. So we'll go ahead and first go ahead and get the keys, put that keys into a simple array, and then from there, as long as we have a list of keys, so we'll then say if our track keys number is greater than 0, i.e. we have a valid list, or we have tracks in the list, then what we'll then go ahead and do is we'll go ahead and set this, and I'm going to be using Kismet math library to get a random to run this random integer function here. So let's go ahead and actually let's go ahead and get both of those includes, since I'm going to need them. I'm going to go ahead and run. For this demo, we'll be using Kismet /gameplay statics, and we'll use this to spawn the audio component, and we'll use the Kismet /Kismet math library to be able to help us, like random integers, like using this. So we'll get a random integer, and then what we'll then do is go ahead and find our track. Now, there's two ways you can use this. You can use playlist.find, and then there's playlist.find.ref or findRef. We're going to use findRef because we don't, because what this will do is it will actually bring back the actual record versus a pointer. If we just use find, it'll bring back the pointer to the to the track in the table, but we actually want the full record back because we want to run it as an out function here. So it'll bring back a copy of what we're looking for versus the pointer. And then we'll just do, since this is now the current track that we're going to be using, we'll do that, and then we'll say return true to say that we found it, we set the track, and what we're passing back is the track that we want to use. Else, if this is not none, then we actually have a specific track ID that we want to bring back. So we'll go ahead and do that. So so very similar, but instead of using an array and having to loop through, or find the track in the array, right? And then all we're going to do is we're just going to come back here and we'll say ftrack music playlist. And again, we're going to bring back the track ID by reference, but since we already know what we're looking for, we'll go ahead and do that. And then just because we brought a track back, again, we'll go ahead and do an if track sound source, and we'll go ahead else, and from here we'll run the error message. Actually, we should do this on the other one as well. So track sound source out track equals track, current track ID true. we should go ahead and do something similar here as well, because just because we have that track, if the sound source is null, then we don't have a track. We could just do that like that. Cut that. And we'll go ahead and just put the same error message down there. Keep that nice and neat. So again, we'll just do a quick check to make sure that we have actually a sound, that there is actually a sound source on that track that's been configured correctly. And that should do it for our function. Let me just double check, make sure everything is there. So again, we'll do track IDs. If it's none, we're going to go and pick a random track, and we'll check the sound. We'll get that. We'll put it in the out, but we'll also check to make sure we have a source. If that's there, we'll put the keys in there and we'll return true. Otherwise, I'm just going to go ahead and return false here. Otherwise, this will just fall through, and it will just keep falling through until we hit false. And then same here. If not, it'll fall through, and then it'll fall through to false. It'll only ever return true if we actually, set that track. All right. So that's our major function. So next up, we'll want to define the isValidPlaylist or playlist table. So this is our validation method function. So let's go ahead and get that done. And that should be pretty simple and straightforward. It's just going to do we're just going to do a pointer check. So here's our playlist, which is a pointer. If it's null, then we'll have we'll fire no table set and we'll return false. Otherwise, if it's not null, we have a table there at least, and we can return true, and we should be able to then continue on with what we're doing. All right, next is can play next track. So this kind of goes into some more advanced play functions that we can test out later on, which will be, so this will allow us to say once the music's ended, if we want it to continue to repeat, this will determine how and when it's going to repeat. So can play next track. Here's our current time. All we're just going to do is we're just going to do a plus equals delta time on that, and then we'll check to see if these two are valid, if this is greater than the next track's time. If this is greater, then we'll just go ahead and set that value, set current delta time to 0 again, so we zero this out so that it can be used again, and then hit return true, which can then say, okay, the next function in that sequence can then play it. Otherwise, if we return false, pretty much we can't play the next track, or we're not ready to play the next track. And then we've got run music state. I'm just going to go ahead and pop that open. Here's our run music state. And all this is just going to be a simple switch statement. So we'll execute our function up here. We're going to, again, pass in delta time. And then we have our current play state, which is our enumerator. So we'll see what it's set to. And then if it's set to repeat, we'll go ahead and do that and break the switch. Otherwise, so we'll just repeat the current track. Otherwise, if it's set to repeat list, we'll just then execute our play next music track list, and we'll define that function a little bit later. And then but then if it's just pick a random, which is our shuffle, then we'll just go ahead and just put an F name just to satisfy the argument, which would be none. It's just going to go ahead and pull random. So we're just reusing these functions, and we just have one additional function here just to go ahead and increment through a list. And I think that should do it for that. So then the only other thing we need next is set next track delta time, which is just a little helper function. And that one, I think I'm going to do this one a little differently. I'm just going to use, yeah, that's right, I just used for that one I just used fmath, and we're just an f range. So here's our min, here's our max, and then here's our next delta track time. So a little differently in finding that random variable from using the Kismet math library, but they roughly do the same thing. Alright, so that defines all of our logic up, all of our internal logic. So now let's just go ahead and define our implementer functions, our publicly facing functions. So let's go to init. So our little initializer function, all this is going to do is it's just going to run the only thing that we need to do is just set this set track time. So we're just going to call this function from init, so when the component gets initialized we'll just make sure that there's a random variable there ready to go and it's not 0. Pretty simple. Call music tick, so this is the one which we're going to piggyback off some other components tick functionality, and this is pretty simple as well. We've already defined it. So the first thing we're going to do is we're going to check to see if the music's playing. If it's playing, if it's not playing, right, then so if this comes back as false, then so we're going to use a not statement. Then we'll run music state on delta time. So if it's playing, we don't want to execute this function. As long as now if it's not playing, that's what this little not statement is here. Say pretty much it says take the opposite of what this says. So if this comes back true, then then treat it as false. Otherwise, if it comes back false, then treat it as true. And if it treats it as true, then we'll run the music state, which is right here, which will then run our can play next track. Okay. Now that we've got that defined, we'll just continue to go down the list. So we've got a set playlist. So these are some simple little functions. So we'll run that. Get current playlist ID, we'll set that. These are just little setters. And the same thing for our enumerator. So if we want to set that enumeration state to a new state, we can go ahead and do it there. We've got our little UI functions. So these are going to allow us, so let's go ahead and run that. Where are you? So let's go ahead and bring that over, and let's just rename this to row, since that's what we're calling it in this solution. So with this one, okay, so pretty much it's what we'll do is we're going to go ahead and create a row of pointers, and then what we'll do is first always check to make sure our table is valid. If the table is valid, then we'll go ahead and get all the rows from that. So this is how we just get all the rows from a data table, and then from there, what we'll then do is what we're going to do is we're going to go and convert this. Since this is pointers and we can't take a pointer out, we need to make a copy of it. So in order to make a quick copy, all we're going to do is we're just going to do a for loop on our playlist row. I'm just going to call it on record. And then as you see, so back here, what we did was we created this additional constructor, or this overloaded constructor with name and description. So all we're going to do is we're just going to go ahead and create that row with just the name and the description, since we don't need any of the additional information for the output. And once it's created its list, we'll just go ahead and return the list. And that's all that does. Next, we're going to do the same thing for the playlist. So this is the individual lists. And that could work a little bit differently, since the map is actually a physical entity. So we don't have to worry. We don't have to worry about pointers. So again, we're just going to go through the row. So again, what we're going to do is we're going to take a look at this, make sure this is not none. So we have a valid name. Make sure we have a valid table. If the table is valid, then what we'll do is we'll go ahead and iterate through that, or do a find row, which will find us the actual playlist by the playlist ID. And what we're going to then do is we're just going to go ahead and return the playlist. Otherwise, if we don't find anything, we'll return an empty map back with no items in it. All right, play music track. This is the function that we're going to use to actually play the music. So we'll go to definition. So again, always check to make sure that we have a valid data. Since we're using data tables, we want to make sure that our table is valid. Next, what we'll do is we're going to go ahead and create that empty soundtrack so that we can use our get soundtrack by ID. So there's our function. There's the track name. So again, that will allow us to determine how to pull back the track. If we find a track, will be true, and we'll also be returning this soundtrack out. And then from there, we'll say check to see, is the music playing? If there is already music playing, okay, so we're going to be calling this. We'll want to stop the current track. And then what we'll then go ahead and do is we'll then call in uGameplay statics and ask it to spawn a new, spawn sound 2D. I'm just going to use this pointer. And then soundtrack, sound source, which is coming from our soundtrack, the volume multiplier, the pitch. And start from, by default, we're just going to go ahead and start our sound from the very beginning. So if you wanted to have something where you wanted to start this music track from a different position, that's where we'd change it. But since all of our music is going to start in the same spot, we're just going to keep that as 0. We keep that as a null pointer, and then here's our persist across all level transitions. Set that to true, and here we're just going to make sure that we're going to set auto destroy to true as well. And that's pretty much it for playing music, spawning a music component, and as soon as it spawns, it'll just go ahead and start playing. Alright, so again, here's a little helper function. So we had that next back up there in the state. We had play next music in list. So here's where we'll go ahead and define that down here. And I'm just going to go ahead and just copy this over, and we'll discuss this code. So again, set that to row. We'll call this a row. current playlist. So there's the current playlist ID. So the first thing we'll always do, again, since we're working with data tables, check to make sure our data table is valid. If it's not configured and not valid, then we definitely don't want to do anything down here, otherwise we'll just crash the engine. Next, we'll go ahead and see if we can find the playlist by the current playlist ID. And if we find that playlist on that table, so there's the table, there's the row coming back. If that's a valid row, then what we'll do, again, we'll go ahead and create an array of keys, since this is using a map. And then from there, what we'll do is we're just gonna go and iterate through, like we're iterating through a loop. So we need to know what the index is. So now that we have an array, we want to know how many tracks are in there. So we'll take the number of tracks -1, since arrays are always 0 based, but the number in it is always more than 1. So we always want to make sure we do a -1, and then we'll go ahead and just do the I++ to just increment I each time we go through the for loop. So then all we need to do is we're going to say track keys at position I. So we're going to do a check to see if the current track is at position I. If the current track is at position I, we're then going to do a quick little check to say, is I at the end of the track? So if I is at the end of the track, then what we want to do is we want to go ahead and go all the way back to the beginning and play the first track in the first track. Otherwise, if it's not at the end of the track, then we'll want to play the next one, which is I+1. So, and that's pretty much it. And then once we hit this, we'll just go ahead and return right out, because we don't need to keep going through the loop anymore. So that's pretty much it, and that's just how we'll do the next music in the list, and that's how we'll just continue to iterate through as we need to. Pause current track. So this is a pretty simple one. All we're going to do is we're going to do some checks to make sure that that we have an object to test on. So the first thing we'll do is check to see if the object is a null pointer. If this is null, we're going to return. Versus if it is not a null pointer, we'll then check to see if this object is in the process of being destroyed. So if it's not in the process of being destroyed, then we'll continue down, and then we'll allow us to set the component to whatever value we're bringing in, whether it be true or false. So do some safety checks on our objects to make sure it's there and it's valid. Otherwise, if we don't do the safety checks and we try and do this, it will again crash the engine, and we don't want to do that. So stop current tracks, same idea. Very simple. We're going to go ahead and run our safety checks first to make sure our component is valid, not in the process of being destroyed. And if it's valid and not in the process of being destroyed by the garbage collector, then we'll go ahead and tell the music to actually stop. And by telling it to stop, it will stop the music. Unlike pause, where it'll just pause it in place, stop will actually stop it. And then if you want to replay it, we have to then go back to play music again. Where if we pause it, all we have to do is just unpause it, and it will pick up from where it got paused. And then lastly, check to say if the music is still playing. And again, it's just a simple check on the component. Again, same idea. Check to see if it's not null. Check to see if it's not being destroyed by the GC. Otherwise, check to see if it is playing. And this one's going to return a true or false. So if it's null, it's false. If it's in the process of being destroyed, it's false. Otherwise, we'll go ahead and check its actual state. And that, I think, will do it for the implementation of our components. So I'm going to go ahead and stop the video right here, and since there's a lot here to digest. And so what we'll do in the next video is we will then take this component and we will go ahead and add it to the game instance. and then from the game instance we can then call it from both a map, so we can start playing the music from a map, and then later on we can then use the same, call it from the same game instance from within inside a widget, so that we can select a music track to play while we're playing the game. So I will stop that here. And again, I thank you for watching my tutorials. If you like what I'm doing, feel free to like, share, and subscribe to my channel. And I hope you have a wonderful day. Thank you. Bye.